Here we go. We're looking at evaluating inverse trig functions, and we want to find the exact value. So that means we're going to want to utilize our unit circle. So looking at number 1, arc cosine of square root of 3 over 2. Inverse trig changes the question. So instead of saying, all right, what is the cosine at this angle measure? It's now different. It's now at what location, at what angle measure does cosine equal square root of 3 over 2? So when you go to your unit circle, you're looking and you see that, well, cosine equals square root of 3 over 2 at these two locations, pi over 6 and 11 pi over 6. But then when you really think about it, we can keep going and going and going around the circle, and there's an infinite number of places where cosine can equal square root of 3 over 2. Because of this, we have to restrict it because we have to make sure that inverse trig is a function. So cosine's restrictions are from 0 to pi. For our answers, we only want to include radian measures that are within that. So clearly for number 1, we can see that our answer is going to be pi over 6 because that's the one that's in bounds. Can't use 11 pi over 6 out of bounds. When we're looking at sine inverse, same thing as arc sine. That one's a little trickier because sine has restrictions from negative pi over 2 and pi over 2. Right? Think sine is vertical, cosine's horizontal. Let's figure out this problem. So when we're looking at where does sine equal negative square root of 2 over 2, that happens at two locations as well. We got here and here. So that is 7 pi over 4 and 5 pi over 4. And what a lot of people do is they look and they're like, oh, 7 pi over 4, that's clearly the answer. But 7 pi over 4, in order to get there, what we would have to do is I would have to go around the circle, go out of bounds, and then hop back in bounds to get there. We cannot do that. What we have to do is we have to start at our initial side and go directly to that angle. So to get from 0 down to 7 pi over 4, well, that would be negative pi over 4. And now we're within bounds. Sine is from negative pi over 2 to pi over 2. You got to really make sure we're not going out of bounds and then come back in. So answer here is negative pi over 4. So watch out for the sine ones. They can be tricky. Back to cosine, I've got arc cosine of 1/2 to the unit circle. We notice there's two places where cosine equals 1/2. We got right here at pi over 3. And then over here at 5 pi over 3. Boundaries are the same. We're only going from 0 to pi. Remember, cosine's horizontal. So pi over 3, final answer. Similarly, cosine inverse of negative 1/2. Remember, that's the same exact thing as arc cosine. Cosine equals negative 1/2 here and here. That's at 2 pi over 3 and 4 pi over 3. The one that's in bounds, 2 pi over 3. Let's take a look at the sine of negative 1/2. You know the drill by now. Draw our unit circle. Sine of negative 1/2 is at, blank for a second. At 11 pi over 6 and 7 pi over 6. But of course, we always have to watch out for the boundaries. Sine's boundaries, negative pi over 2 to pi over 2. In order to get to 11 pi over 6, we go out of bounds and back in. That's not okay. So what we'll have to do is go backwards, pi over 6. When we go clockwise, that's going to be negative. So negative pi over 6 is our final answer. For tangent of negative 1, tangent is negative in two places, in quadrant 2 and quadrant 4. So tangent's equal to -1 here and here, which are at 3 pi over 4 and 7 pi over 4. Similar to sine, tangent is also tangent inverse. The restrictions are also from -pi over 2 to pi over 2, but not including because tangent is undefined at those two places. So we got our boundaries here. The angle 7 pi over 4, well, that looks like it's in bounds, but it's really not. We got to be careful. This is another one of those we'll have to go backwards. So you go backwards, pi over 4. So -pi over 4 is our answer.